Welcome back to Derivability. Today let's take a look at double angle and some half angle identities in trigonometry. Okay, what you see on the screen right now are some identities for sine, cosine, and tangent. Okay, I talked about those in a previous video, so go check that one out if you want to see that. Okay. Now, generating these double angle identities is really not a big problem after you have these sum identities. Okay, so for the double angle identities, what we're going to do is we're just going to set these two angles equal to each other. So I'm going to replace all of the phi's in every single one of these with theta, or you can do it the other way around. Okay, and then all of a sudden you get double angle identities. All right, so for instance, for the sine, we have sine of theta plus theta should be identical now to sine theta cosine theta plus cosine theta sine theta. Well, of course, this is just the same thing as sine 2 theta. Identical to, and then these two terms on the right hand side really are themselves identical, just with the factors written in opposite order. So 2 sine theta cosine theta. Okay, there we go. All right, now the same can be said for cosine here. We have cosine theta plus theta identical to cosine theta minus sine theta sine theta, or you can probably see here without a lot of trouble, cosine 2 theta will then be identical to cosine squared theta minus sine squared theta. Now, it turns out there are two other options on how we can write the cosine 2 theta identity using a Pythagorean identity that you probably already know about. Okay, I'll get to that in a few minutes after we finish our list of 3 here with the tangent double angle identity. So here we can write tangent theta plus theta identical to tangent theta plus tangent theta over 1 minus tangent theta times tangent theta. And as before, we see that this is tangent 2 theta identical to 2 tangent theta upstairs, and then 1 minus tangent squared theta downstairs. Okay, so not a lot of fuss to generate these double angle identities. All right. Now, here in a minute, I'll create some clean space, and we can check out that there are 2 other options on writing this identity for cosine 2 theta. Okay. Now we got some clean space here. Over in the typeset equation on the left, that's the cosine 2 theta identity we derived a few minutes ago. All right, and then you guys, I'm sure, recall this Pythagorean identity. Okay, it's among the very first identities that you learn in trigonometry. Sine squared theta plus cosine squared theta is always equal to or identical to 1. Okay, now it's an identity in addition to being an equation, but we can solve it as if it were an equation. Okay, so we can solve that for sine squared, or we can solve it for cosine squared. Okay, now if we solve it for sine squared, we can take 1 minus cosine squared and put that in place of the sine squared. And if we do that, we get cosine 2 theta identical to cosine squared theta minus 1 minus cosine squared theta. Okay. Or if we distribute through the parentheses, okay, there's the cosine squared we started with, minus 1, then plus cosine squared theta. So we get an alternative cosine double angle identity, 2 cosine squared theta minus 1. Okay, there are times that the original up there is more useful. There are times that this one's more useful. Okay, furthermore, we can substitute for the cosine squared using 1 minus sine squared. So if we do that, cosine 2 theta identical to, okay, now 1 minus sine squared theta, in parentheses, minus sine squared theta. Okay, now the parentheses here, unlike before, are really not necessary, but I've just put them there for emphasis. We can remove the parentheses without any sort of problem, of course. So 1 minus sine squared theta minus sine squared theta. So we get the finally the third version, cosine 2 theta, identical to 1 minus 2 sine squared theta. Okay, so 3 possible identities for cosine 2 theta. This kind of depends on what your needs are, what you're trying to use it for, what maybe you're trying to prove a different identity. Who knows what? Okay, now in a minute, we will take a look at half angle identities, which are kind of the reverse of double angle identities. And for those, we will actually need these 2 versions of the cosine double angle identity. Okay, so I'll put those up at the top of the next screen after I create some clean space, and then we'll take it from there. All right, new screen now. Okay, you can see I have these second 2 of the cosine double angle identities ready to go here. And we're going to generate some half angle identities basically by doing these in reverse. All right, so let's let 2 theta equal phi. So our double angle, you might say, now becomes a single angle. And then if we solve that expression for theta, we get theta equal phi over 2. So now our single angle becomes a half angle. Okay. All right, so let's solve that for our new half angle. Okay, so here we're going to have cosine phi identical to 2 cosine squared phi over 2 minus 1. Okay, or 2 cosine squared phi over 2 identical to 1 plus cosine phi. Cosine squared phi over 2 identical to 1/2, 1 plus cosine phi. And then we can finally get this half angle by taking the square root of both sides. Okay, except you guys know that you have to allow the possibility for a plus or minus when you do that. Okay, so 1 plus cosine phi on the inside there, excuse me. All right, now what about that plus or minus? The reason we have that is because we don't know the quadrant of the angle that we are dealing with until we have a specific angle in place of phi, or phi over 2. Okay, so the plus or minus here is determined by the quadrant of phi over 2. Okay, so for instance, if phi over 2 is in the first or fourth quadrants, then we're going to have the plus. If phi over 2 is a second or third quadrant angle, cosine will be negative. We choose the minus. Okay, all right, so half angle identity. Now for cosine, okay, let's do the same thing to generate a half angle identity for sine. So as before, we're we're going to use this other identity, but we're going to do the same procedure. We're going to let 2 theta equal phi, or theta equal phi over 2. Okay. So in that case, we're going to have cosine phi identical to 1 minus 2 sine squared phi over 2. Okay, let me put that negative term, sine squared term, on the left where it becomes positive, and then the cosine phi term on the right where it becomes negative. Okay, so next, sine squared phi over 2 equivalent to 1/2 1 minus cosine phi. And then as before, our last step is to take the square root of both sides. Okay, but because our angle, or at least its quadrant, is indefinite, then as before, this plus or minus sign is going to be determined by the quadrant of phi over 2. For sine, if the angle phi over 2 is in the first or second quadrant, we choose the plus. If it's in the fourth or third quadrant, we choose the minus. Okay. Realized I forgot to put the triple line equal sign down here, because these really are identities, not merely equalities. Okay. All right, so now we have our half angle identities for sine and cosine. Just the procedure we happen to use with this substitution. I have these written in terms of phi, but if you want to, you can go back and use angle theta. Okay, by now you probably understand that about these identities. You can name the angle anything you want to. Okay. All right, now what about the tangent half angle identity? Okay. All right, well, let me create some clean space, and then we'll kind of talk a little bit about it. A more thorough discussion with actually other options for the tangent half angle, I think I'm going to have to put in another video. Okay, but we will at least get the ball rolling. All right, so we're back to it here. Here we have the half angle identities for sine and cosine. All right, so tangent, as you well know by this point, is the same as sine over cosine, but if we're going to do the tangent of a half angle, we also have to do the sines and cosines of the half angles as well. So let's just use what we have here. So for the sine, that's plus or minus root 1/2 parentheses 1 minus cosine theta. And then for cosine theta over 2, very similar, 1 plus or minus the root of 1/2 1 plus cosine theta. All right. Okay. All right. Now we can simplify this just a little bit, and we get tangent theta over 2 identical to. Now we have a plus minus in the numerator, same in the denominator. Now, those don't cancel, because you could have a plus or a minus in the numerator, which could pair with a plus or a minus in the denominator. Okay, so you could actually get plus plus, plus minus, minus plus, or minus minus. So you still have the possibility of a plus or a minus sign here. Okay, we could bring all of our operations inside of the root. Okay, as you know about roots and fractions. And then we get our factors of 1/2 to cancel. Okay, and then we're going to get down to our final version of this, at least for right now. Tangent theta over 2 is equivalent to plus or minus the square root of 1 minus cosine theta over 1 plus cosine theta. Okay. All right. Now, there are two things about this that are maybe a little less than attractive. One is the plus or minus. Okay. Now, those plus or minus signs up here just couldn't be avoided. Okay. Now down here, maybe it can be avoided, maybe not. Okay. Also, we have roots, and again, maybe you can avoid the root, maybe you can't. Okay, and again, for the sine and cosine identities up here, there really wasn't any avoiding those roots. Maybe there is for the tangent. So in an upcoming video, you can expect sometime soon, I'm going to show you 2 additional identities for the tangent of a half angle, neither of which requires the use of a plus-minus symbol or a root. Okay, so in some ways they are superior to this one. Okay, but I think this is a good place to stop for now. Thanks for hanging around with me here at Derivability. Okay, hope you're enjoying learning some trigonometric identities. Please share the channel, this video, and other things with your friends, classmates, maybe even your teachers would be interested. Okay, hope this has been a helpful thing for you, and we'll see you again soon.